let's take a look here at this 2.7 section. So we're going to go right into this here, see if we can get through a good deal of this, because there's a good deal of graphing on it. And actually, this month, there is a lot of graphing, as you've already seen. And graphing is one of those things that you learned in the past, and you were supposed to know well. So if you don't and didn't really be good at it, here's a chance where you can get better at it, which means get some help if you need to. I'm available at Math Help Times. You can get help from other people, but you really want to be better at it because there are like 9 or maybe 10 graphing questions on the test. Like 7 of them, you actually have to do the graphing. Some of them are you recognize something and take information out from the graph. So many of them are like this, where you will actually have to make the graph for me, and I'll have to see the graph. So you want to be good at that, and if you aren't yet, come and get some help and practice it so that you will be good at it next week. Okay, but that means you need to focus on really doing stuff. So I'll go over what to do on some of these, so there'll be a good review if you do know it, or if you didn't know it and weren't sure, this will be good for you to see the right ways to do it, so you will get better at it. Because I would be perfectly happy if you got all the questions right on graphing on the test, and the other ones too. But let's work on the graphing ones. Okay, so we're going to do a linear inequality. That means it's the greater than or equal. Whenever you see inequality and you see those signs, that means it's going to be where like part of it's shaded like that. So we're going to end up with a result where it's shaded. That's one of the reasons that usually these type have to have a graph, because it's not just a single answer, it's an area, a region that's correct. And that's what we will find out here. So the idea of having this is that it's a straight line that's the border. And what I want to do is I want to graph where this border is, wherever that line is, and then figure out which side to shade. So the easiest way to graph this, you have 3 ways you can always graph these, remember. You can use x and y intercepts, you can do an xy table, or you can change it into slope-intercept form. So if you are not sure what to do, make an xy table and plug in a few x's and get the line. I personally like to use the y equals mx plus b format, so I'm going to do that one here. But if you prefer doing xy tables, go ahead and do that. You'll get the same result. It won't matter which way, because it's another one of those things in math where there's multiple ways to do the same thing. So I'm going to make this an equal sign for the purpose of finding where the line is. That means I'll move the x over here. So I'm going to get negative 5y equals negative 3x plus 21. I'm going to put the x term right after the equal sign to get the y equals mx plus b format. But I'm going to have to divide by the negative 5. So y is equal to 3 over 5x minus 21 over 5. Now, that means I have here the slope, and here I have the y-intercept. It's too bad that wasn't a 20, because that would just be 20 over 5. That would be 4, and I could go right here to 4 and work, whoops, negative 4. I could work with that. But that's very close to 4, so I can work with it anyway.
Yes. If you're looking for a decimal, it's 4.7.
Yes, and that's the thing, is I could do it as a decimal, or I can make it a fraction, because that's going to be either negative 4 1/5 or negative 4.2. And negative 4.2 probably, for most people, would make more sense to work with, because you know it's just past the 4. But so would 4 1/5, so basically whichever way you're comfortable with. Because the purpose of this wasn't to make that, it was to figure out where to go. So this doesn't make sense where to go, but these do. So negative 4 and a little bit past it, and that's where we'll be. And our slope is 3 over 5. So that means a rise of 3 and a run of 5. So I'm going to go up 3 and then over 5. So starting from here, I'm going to go up 1, up 2, up 3, and then 1, 2, 3, 4, 5. So again, right a little bit under that to match the other part. And I could do it again, but that's actually enough if I use a ruler to get the line. Here's the problem. I have to make sure, because it's an inequality, I have to decide, is it a dashed line or is it a solid line? And that's where the little line underneath the greater than part comes in. That says greater than or equal to, and if it's equal to, it's a solid line. So I'm going to use a solid line this time. The next problem we do, we'll have a dashed line, so you get some practice doing the dashed lines. Okay, now I have to bring up something about my lines and your lines, because you're the one going to draw these. I have a couple little rules for these lines. This here is a segment. If I leave it like this, I'm saying it starts here and it goes to here, and it doesn't go beyond. But the whole point of a line with the variables in it is it goes forever. It goes forever that way, and I need to show that. And it goes forever that way, and I need to show that. If you don't put the arrows, you're going to get a point off. You have to put the arrows. Because if you don't put the arrows, you're telling me it stops and it ends. Or it starts and it stops. Or it ends and it starts. Whatever it is. If you do put the arrows, you're telling me it goes forever, which is what it's supposed to do. So make sure you put the arrows. And the other thing is that this is not going to be part of it, but let's say that the points were here and here, and you just did a line like this. That's not good enough. The line has to go all the way through the graph. So this would have to continue through. That one's close enough. But this one would have to go all the way to the end of the graph area, and you'd have to graph that and show it. So make sure that you go all the way through to the ends, and that you put the arrows. Those are my two big little pet peeve things for drawing lines on graphs. Okay? If you had full page of graph paper and you were doing like a graph on part of it, you wouldn't have to go all the way through the whole paper. You just have to do what's reasonable. But you would have to put the arrows. Okay, so that's really part one. So all of this I'm going to call part one. If you had done an XY table and put in 3 points and plotted them and done the same thing, that would still be part one. But the next part is figuring out where to shade. And this is where you just pick a point on one side or the other and just test it. Now, I could choose, what's that, 7 and -8. But if you have 0, 0 available, that's much easier. So you go back to this original and use the point 0, 0 and plug a 0 in for x and a 0 in for y, and 0 minus 0 is 0. And you see, is it true that 0 is greater than or equal to 21? No, it is not true. So because that's false and 0 is not greater than, that means you go to the other side where 0 is not there and you shade that. And it doesn't have to be like perfectly artistically shaded. I just have to be certain that you know what part of it makes the correct answer. Because any point in here would make a correct answer. Yes?
Shouldn't it be y is less than or equal to because you divided by a -5?
If I had done that here and not had it equal, that would have been true. But you notice that when I put the 0, 0 in, I went back to the beginning part before dividing by the -5. I purposely did that so I didn't have to worry about switching the sign. So if I had put the sign in here and did that and then tried to put the 0 in here, then it would have mattered. But I purposely avoided it because I didn't want to worry about switching it.
Can't you also just look at which way the sign is facing and shade whatever that is?
Only if you use it with y equals. Like right now, you can't always tell that for sure because it actually looks as if y is greater than it, unless you realize the negative would switch it. But that's a little, you could do that if you think about it and you understand it. But for most people, it's probably better to put a point and be absolutely certain like that. Because some people wouldn't recognize what would happen with the negative, or something would be confusing to them. So you could do that if you're certain. I would be safe and plot a point just to be sure. And 0, 0, since it's available, is a really easy one, because I go back here and 0 minus 0 is 0. 0 is not greater than 21. That's why I go back to the original too. Just because in some cases there'd be no negative, it would be easy to do. In other cases, I want to be safe. This one's a little bit easier because it's already set up. So you could do that here. Okay, that would be the answer I'd want to see if this were a problem to do. Let's take a look at the next one because now it's an absolute value inequality. And first thing, it's an absolute value. Whenever it's an absolute value, it's automatically going to be a V shape. Okay? It might be going down, it might be going like this, it might be moved around, it might be like over here or down here, it might be upside down, but it's still a V shape. It's always a V shape. So when you see that, make sure it's a V shape. I can't tell you, because I can't count that high, how many times there's been an absolute value question on my tests, and somebody has made it a straight line all the way through the graph instead of a V shape, because they didn't plot enough points to check to be sure where it turns. And so you know that you need to find out where it turns. Okay? The easy way to do that is to take the middle part, the one in here. What makes it 0? 2. If I put a 2 in here, I get a 0. So that 2 is the x value. That would be the place where the little vertex point where it turns. And then I use this number and that's going to be the place, 2 and 3. 2 and 3 is going to be the vertex. So for this one, I will always revert back to these to graph a few points, because over here, I could have done that here. I just like to make that into a y equals mx plus b slope-intercept form. I can't do y equals mx plus b the same way here. Pardon?
That's 3, 3 on the graph.
Ooh, you're right. Thank you for catching that. So it should be here that I'm at. Please ignore that little dot. Okay, 2 and 3. Now, that also, this one that makes it a 0, the 2 that would make it a 0 inside, and notice I pay no attention to the 2 for that, or the 3. I just need to know what makes it 0. That's my middle point for the xy table. Okay? And I'll make that 3, because if I do 2 minus 2, that's a 0. Absolute value is 0 is 0. 2 times 0 is 0. Plus 3 is 3. And now I'll do a couple of points either way. Negative 3, or positive 3, positive 4. So down a couple, up a couple. And let's say I put 0 in here. 2, absolute value 0 minus 2 plus 3. Well, that's 2, absolute value negative 2 plus 3. But the absolute value, that makes that a positive 2. So I get 2 times 2 plus 3. 4 plus 3 is 7. 0, 2, 4, 6, 7. I actually don't really need to plot this one because I know that's going to be here. That's going to be this point because I know I'm going to go up like this. So let's check and see if the other one over here is also 7 because these are going to match each other. Let's actually check that one here. 2, 4 minus 2 plus 3. 2, absolute value of 2. Well, its absolute value of 2 is 2 anyway, so that's 4 plus 3. Yes, that's 7. 4, 7. Okay, so now if I plotted these, if I put 1 in here, get a negative 1 or a 1 times 2, that's a 5. So I would get 5 for the other ones too. Okay, now, I did something that could be a mistake if I don't correct it. What's that?
Dotted line.
Exactly. Because that is a less than only, this should have been a dashed line, and I wasn't thinking about it. What I should have done when I did this is I should have made it dashed first. And what I'll do now is I'll sort of go on it, and if I were a student wanting to make sure a teacher knew that was dashed, I would write dashed to make sure it was really clear that it was supposed to be a dashed line. So it's better if you make it dashed line, but if you forget, then try to draw little dashes next to it or make them bigger and write the word dashed in case you forgot. Make sure that it's very clear to me that it's supposed to be a dashed line. This one up here was supposed to be a solid line, so it's good to go. Here, I should have thought about it before I drew the line. Okay. Well, once you do that, and you notice here, what I've done is I've done this as if it was y equals the absolute value. So I've made where the line is, now I need to figure out where to shade, and it's the exact same thing as it was up here. Pick a point on either side. Now, you can sort of figure out, because this is set up with y less than, all the y's less than, I should be shading out here. I'm going to check it and be sure, though, by using 0, 0 on the outside. I'm going to say 0 less than 2, 0 minus 2 plus 3. Well, absolute value, actually that's this one over here. 0 minus 2 is negative 2, absolute value of negative 2 is 2, so that's 2 times 2 is 4 plus 3. 0 less than 7, that's a true statement. It comes out true. So here, the y's less than and this being true all mean the same thing. I'll shade here. Okay, there, whole thing shaded. And that's pretty important because, you know, when I give partial credit for problems, I'm really looking for that at least the main thing is there. Well, if you graph that but you don't do any of this, then you don't get even the main point as to why it was an inequality. So make sure you really think about and are careful about where you're shading it so you get full credit on a problem. Okay. So these two problems are very similar. This one's a little harder because it has to do with the absolute value, and that's why I want to remind you, make sure you do this and use this middle thing the thing inside the square root to help you figure out where to start, to figure out where it makes it 0, and that's your starting place for the table. Okay. So you will be graphing, like I said, a bunch of things. You could be really pretty sure you're going to graph at least one inequality, probably 2 of them. And that means this is probably these are probably the kinds of things you need to know. Okay, so practice ones that are similar to this.